All right, everyone, let's go ahead and get started. Thanks for joining us. My name is Tony Guay. I'm a remote sensing specialist with the Wheatland Geospatial Lab. And I will mention as we get started that I'm recording this session and we'll be posting that to the Wheatland YouTube channel. There's a link to all of our social media on the Wheatland Lab website, wheatlandlab.org. So that'll be available after today's seminar. And I hope you guys are all safe and healthy and doing well. And just by way of an introduction, I'll mention that Adam joined the Canadian Forest Service in 2018 after more than 10 years with the New Brunswick Department of Natural Resources. He held various positions at NBDNR, including coordinator of the New Brunswick Growth and Yield Unit, wood supply analyst, and manager of inventory development, where he led LiDAR acquisition and enhanced forest inventory adoption. In his current role as forest research project leader with the Canadian Wood Fiber Centre, Adam continues to support adoption of EFI across Canada through research and collaboration. He is also focused on integration of EFI and other data streams into improved decision support tools from operational to strategic scales and across the forest value chain. So with that, Adam, I'll just turn it over to you.
Okay, great. Thanks, Tony. So good afternoon, everyone. Welcome to my basement office. I'm still working from home over here. Hope everything's doing well on your side of the border. So just mentioned, yeah, I usually get down into New England every fall for the menstruationist meetings, and Aaron Weisskettel had it planned for Stowe, Vermont this year, and I'm kind of looking kind of disappointed that I won't be able to, that it's not going to happen this year. It was always my chance every fall to get in the car with my own thoughts and go for a drive through New England and yeah, make some plans for the fall and into the winter. So I have to figure out how to do that another way. So thanks for inviting me to give a talk. I'm going to go over sort of in terms of the Fiber Center, what we've been doing over the past little while and to work on enhanced forest inventory and the adoption of those tools. And then shift into really where we're moving our focus now. Not that we're saying that enhanced forest inventory is solved and we have all the tools that people will need, but you know, we started to realize that it's great to have a high resolution forest inventory, but if you don't move the yardsticks on the decision support tools that you're gonna feed that data into, it's really hard to justify, you know, have I really made any incremental gains, because it's difficult to prove that I've improved my decision making. And so we're starting to focus on that, really, you know, pick up the EFI and figure out, you know, how do we need to change the way we think about the problems that we're using that data on to make better decisions. So I am with the Canadian Forest Service. Okay, there we go. Just figuring out how to advance slides in this framework. So within the Canadian Forest Service, we have our regional centers. I'm in Fredericton, New Brunswick. We have sort of our main centers are in Fredericton and Quebec City, and Sault Ste. Marie, Ontario, in Edmonton, Alberta, and then in Victoria, British Columbia. And each center sort of has a mandate or a focus. So pest management, for example, in Fredericton, wildfire in Edmonton. And then the group I'm involved with is the Canadian Wood Fiber Centre. And so we're a little bit more dispersed. We're about 50 of us or so within the Fiber Centre, spread across the centers across Canada. So it's been very good for me through this COVID period, in that, you know, we were already distributed, we were already well attuned to using remote conferencing tools and video chat and things like that. That's kind of how we were designed up front, and that's how we operated. We worked with our colleagues across the country to begin with. You can kind of break our focus into three broad bins. One is sort of understanding the characteristics of desirable wood fiber. So, you know, you can see a guy looking through a, you know, wind dendro machine or something, looking at fiber properties. You know, what, you know, if I'm setting up a pulp mill, what is the ideal fiber that I need delivered to that pulp mill? What are the characteristics of the wood that make good pulp, for example? The middle one under blue is sort of the forest inventory aspect. So, you know, once I understand what is a desirable tree to turn into a given product, you know, how do I understand where those trees are in the forest? How do I identify where they are, and how do I fit that into strategic management planning and so on? And then on the right-hand side, it's, you know, around producing the trees with desirable characteristics. So that's around tree improvement, tree genomics, and so on. Understanding, you know, when we go through reforestation, when we do silviculture activities, you know, how can we modify the forest conditions out there to create the tree conditions, the tree qualities that we need to supply the forestry sector. And, you know, I talked about the forestry sector, but I would say it more broadly as, you know, a whole suite of forest values. So, you know, produce a tree with a desirable characteristic might be for a cavity nesting bird, for example. And so that would fit under that umbrella as well. Our research program, we renew every 3 years or so. So this year was the start of our new three-year research program. And you'll kind of see those themes come up again. So output one is characterizing biomass and enhanced fiber production for the bioeconomy. There's a real push in Canada, and I'm sure elsewhere, to move into, you know, beyond pulp and paper and structural timber products. You know, what can we do to produce a whole suite of products out of a tree across the bioeconomy value chain? You know, produce, so looking at forest productivity, carbon sequestration, silviculture, you know, a lot of the inputs we need to help making decisions, so improving soil productivity mapping. Anticipate is around growth and yield modeling, understanding how today's forest conditions are going to grow into future forest conditions, and really under that one, this time around, we've put a focus on climate change. We're putting together a large 5-year research program now around silviculture and growth and yield in response to climate change. And that shows up again in the adapt one. So, you know, given climate change, how do we adapt our forests to be more resilient, continue to produce the values we need, but you know, being able to allow them to thrive in a changing climate environment. And output 3, the orange one over top, is sort of where I'm working. Is we realize, you know, the portfolio of projects that we've worked on in the past, we started to need an integrate bucket where we start all of these tools that are coming out of these themes. How do we make them mesh together and really turn into tools that are you know, the forest sector, that our provincial partners can take, you know, beyond a research paper or a technical note, but really have tools that people can start using and making sense of the work that we're doing. I don't want to be punny, but I wanted to make you aware of the AWARE project if you're not already. So we're just wrapping this up now. It was a Canada-wide research program headed out of the University of British Columbia. Dr. Nicholas Coops was the lead. Really looking at remote sensing, very applied. We had some core research forests across Canada. We had industrial partners in many provinces across Canada And we paired graduate students and university researchers with forest companies who had specific questions that, I need a remote sensing tool that will help me do this. We had, across the spectrum of resolution, so, broad climatic, broad regional questions. We had stand and operational, sort of more forest operations questions, and then down into, individual tree questions. A lot of LiDAR involved in this. The website for the AWARE program is up in the upper left-hand corner, and so I encourage you to, if you're not already up to speed on what we've been working on through that program, it's a pretty comprehensive website, and it's really starting to show a lot of the results that that are coming out of that program. In terms of CFS and the fiber centers work on enhanced forest inventory, that's really been a thrust of our work over the past 10 years or so. We have some very good best practices guides that are published by Joanne White, Mike Wolder, and others. First on sort of understanding airborne LiDAR as a tool, and sort of what are the best practices for if I want to, sign a contract to acquire an area. Things about point density, flight line overlap, scan angle, and things like that. And then the second one dives into, if I want to start building models that produce my EFIs, what are some best practices around developing EFIs? And they've been well received. They're very good guides to get you up to speed quickly. The other tool, I guess, to mention is the LiDAR package that was developed out of the AWARE program. Actually, it's an R package that, if you're familiar with the US Forest Service Fusion package, integrates a lot of that functionality into R, has tree and crown segmentation, identification algorithms, a lot of the last tool functionality in terms of normalizing point clouds and such is in that LiDAR package. So it's been a real Swiss Army knife for me to get work done. So here we are in New Brunswick. In New Brunswick, and as Tony mentioned in the introduction, I was on the provincial side up until not too long ago. Really led the charge on taking that research out of the Fiber Center and saying, all right, we want to use enhanced forest inventory as the basis for our inventory program in New Brunswick, using the best practices guides and making it happen. And so between 2013 and 2018, all of New Brunswick was acquired with 6 point per square meter LiDAR, airborne LiDAR. You can see the canopy height model for the entire province on your screen there. And this is sort of the point we're getting to here, is we've got all this new data. We've got, just to put it in context, previously in a strategic management planning context with, aerial photography and photo interpretation, the province would have been delineated into a bit over 1 million polygons, forest polygons, and we would have further distilled that down into about 635 yield curves to really start making strategic level decisions. So, a really simplification of those conditions. On a EFI with a 20 meter by 20 meter grid, we're up to, almost 170 million EFI cells, where we're predicting every 20 meters basal area, volume, average tree height, quadratic mean diameter, biomass by component, and so on. And so it's just an explosion of an amount of information that we have at our disposal. In some cases, we're getting down to the tree level. We can conceivably take that canopy height model and delineate trees out of it. And so, by rough estimate, 12 billion trees that we could delineate out of that provincial picture. And so how are we going to deal with all that data? How are we going to make sense of it? How are we going to shoehorn it into our decision models? In the absence of developing any new tools, what people have been doing is dumbing that data back down into the polygon level, into the yield curve level, and running it through their same decision tools that they're used to using. And so, in a lot of ways, they're squandering a lot of that opportunity that we've provided them. And it's not they're not to blame for that. It's not their fault. It's it takes time to develop those tools and understand what we need to do to move on and really truly adopt that data as a rich data set. And so that's where we're starting to work. The left-hand side here gives a really good overview of sort of the hierarchy of forest management planning, from the strategic down to the operational. And it gives a good framework for where we're headed and where we really want to focus things on. So traditionally we had, as I said, that photo interpreted strategic inventory. We did strategic inventory with it, or strategic planning with it, kind of skipped over the tactical, and then sent a bunch of guys out in the woods to, scan, to cruise a very smaller amount of the forest to figure out where you're going to send your harvest operations and so on. The framework we see here is really showing the integration between those hierarchies. The arrows pointing down and coming back up are very important. We've got this forest operations control on the bottom, so that's really suggesting that, we need to get past, the inventory said I could do this here. I went out and I cut it and I got that, and the inventory is wrong, and seeing that as a problem, but never sort of really comparing the notes between why did I get it wrong between one and another, and how can I feed that intelligence really that I'm developing every time I cut the forest, and feed that back into that loop to make sure that the next time I go to a harvest block, I'm not only working with my inventory that predicts what I have there, but I have some knowledge of, well, the last time the inventory in this sort of a condition, it was off by 20%. So I should keep that in mind. And so just to reinforce that, this is a map produced in 1984. As some of you may know, New Brunswick was an early adopter of EFI ARC Info. In fact, I think we have serial number 2. We were the second customer for EFI ARC Info. And so this map here is out of the ESRI map book from 1984. It might have been the first map book produced for their user groups. And New Brunswick was quite prominent in that map book. So I scanned it. This is planned harvesting from 1983 up until 2013. That was published in this map book in 1984. So, there was no color back then. You can see the hatching and kind of get a sense of what blocks were scheduled into what periods. And at the bottom too, it gives a whole lot of information about the decision support tools that were put to bear on that to get at that decision. So, about growth and yield modeling, wood supply modeling, harvest objectives, and so on to arrive at that planned schedule between back then and 2013. So I actually georeferenced this back out of the map book and said, all right, well, in the early 80s, they planned to do this. How well did we stick to that plan? So, I've got this map now, and then I'm going to superimpose over what actually got harvested over the subsequent 30 years. And you don't see a whole lot of overlap between the two, which, and again, that's okay. So there's been policy changes in the past 30 years. The forest sector has changed. There's a whole bunch of reasons why what I had planned to do 30 years ago and what I actually did has changed. I got to a block and it was too wet. The trees were too small. But the question is, what have we really learned in the past 30 years of, how well have we kept track of, I planned to do this, but I did that. Why did I have to change my decision? How do I use that to help me understand when I get into this pickle the next time, I could at least have anticipated it and maybe tried to be a little bit more nimble and change on the fly, a little bit more deliberately rather than in an ad hoc fashion. So that's sort of what we're trying to not get ourselves into this time around. We've got a better tool. This is the canopy height model, currently over the exact same area. So it really speaks to, it's not enough to just have data. You really need to have the decision framework around that data to really leverage it and help you make better decisions. New Brunswick's really complex in terms of our value chains. On Crown land, so Crown land, publicly owned land, is about 50% of the land in New Brunswick. Managed quite intensively. We cut 100% of our AAC. We're near a low point in our growing stock. We've got a diversity of raw materials, same as in Maine. You know, we're in the Acadian forest. There's lots of species. There are a lot of things you can do with the raw materials coming out of the forest. We've got a forecasted decline in hardwood AAC. We've got a surplus of softwood pulp. In the last downturn, we lost a lot of pulp mills in New Brunswick. There's non-timber objectives laid on top of our management plan framework. Complicated supply and transportation chains. We've got another 30% of the province that's private land, where there's lots of opportunities from there. You know, and maybe there's opportunities for, out of all this, for new mills, further investment if we knew what the opportunities were. One big point through this COVID-19 is, you know, we need more agility to capture expanding opportunities. So if we need more of a specialized pulp to make masks, for example, or everyone's building a deck this summer, where am I going to get all the pressure treated lumber from? These are, you know, good concrete examples just in the past 6 months of how quickly the pull out of the forest supply chain can change based on consumer demand. On the right-hand side here, just quickly, this is one timber license. So Fornebu is the manager of this about 1 million hectares of forest. All of those companies down on the left-hand side actually get, you know, a bit or a piece of the forest products coming out of there. You know, and it's very specific by species, by product sizes. There's wood chips being traded from sawmills to pulp mills. Fornebu, who manages that license on behalf of the province, only actually consumes about 20% of the harvest that they plan for. All of these other companies take the other 80%. So it's a very diverse value chain. This company that needs 20% of the wood needs to manage the other 80% on everyone else's behalf. And so, you know, that can be fraught with issues of data transparency and all kinds of issues around that. We've realized, you know, there's a whole bunch of new data sources, digitized data sources that are additionally available out there. So obviously LiDAR and remote sensing and EFI. You know, in the past 10, 15 years, things about harvest updates, health monitoring, disturbance mapping, those have all been transformed into digital data streams, maybe not real time, but you know, quarterly or annually or monthly, we're getting updates on those. How can we, you know, feed that back in more quickly? Forest operations, you know, in terms of all of our planning, there's a digital breadcrumb created along a lot of those. And, you know, a lot of these data sets are currently siloed. You know, we don't really treat them as how do they intermesh with one another? How do they start creating these feedback loops? Right from the mills, we've got you know, information about, you know, mill inventories, you know, how they're changing in response to customer pull out of a mill and so on. And that's a real, you know, you can almost draw a line right down the middle of that screen. Once the wood gets to the wood yard, the guys on the mill side really don't talk to the Woodlands guys and talk about how the wood got there. So we want to break down that barrier between the, you know, a lot of more transparency between the mills and what's coming out of the forest. So we're getting into some concepts around big data. You know, there's some important elements that we've learned about big data. You know, obviously the size of the data is important, but the other much more important aspects of it is, you know, the velocity, the speed at which you can get that new data. The variety, as we just talked about. The veracity is really important. So, you know, you just can't get a pile of data. You need to trust the data and have an understanding on where it came from and how accurate it is. And, you know, what are the pitfalls of using it inappropriately. You know, and finally, you know, just having a pile of data is of no use to you if you can't generate value out of it. So these are things that, you know, we really want to start talking about. I was shared this diagram a little while ago. Shows the difference between data, information, knowledge, insight, and wisdom. I think it does a good job. I actually traced it back to the origin. When I was first shared this, I got this diagram here, which was a little bit different. But yeah, people have been taking this diagram and shoehorning whatever message they want to infer out of a bunch of points, random points, and build a bunch of messages out of it. But you know, it really, you know, the left-hand side reinforces, you know, data is not information, is not knowledge, is not insight, is not wisdom. You really need to draw the lines between the information and understand, you know, how are you really going to get value out of it. So we've been working on some collaborations within the Canadian Forest Service or the Natural Resources Canada. We have CanMed Energy. They're based outside of Montreal, and they're really focused on, you know, they'll go into an oil refinery or a pulp mill and look at all of the instrumentation and the data streams coming off of big machines and, you know, throw advanced analytics against it to understand how can I improve my product outflow or improve my energy efficiency and so on. And so we've been working with them as a strong analytical team. FP Innovations is another group that we support that works more closely with forest sector on operational questions. And so they've been an important partner. And then the work that we do at CFS at the Fiber Center that are already outlined. So we've been trying to work more closely together on, you know, trying to come up with some projects on forest value chain optimization, getting all these data streams into an algorithm and hopefully getting some better decisions out the other side. In February, and I'm in that photo, that's the last time I was in a group, pretty much. It might be a long while before we can do that again, sit in the same room and have a 2-day workshop. But we organized one in Fredericton. We had a cross-section of forest industry from the province, some other government organizations. We had some experts on value chain optimization, both from universities in Canada. We had Emily Heitinen from VTT in Finland come and give a Scandinavian perspective on where they are on deploying some of these tools. And really had a good opportunity to get folks up to speed on, you know, what are the opportunities from taking all these data sets and working with them differently to get to better solutions, and really trying to nail down what would be some initial priorities from stakeholders that we could start working on. So in terms of key priorities that they identified, EFI, as I said, we're not by any means done with EFI. There's some further improvements that we need to make with that. One is continued work on species identification, volume and product estimation, and that's one that's obvious. You know, we're when we build an EFI, we, you know, use high resolution LiDAR data, and then, you know, we might predict basal area or tree height very precisely, but then we throw a volume equation into the mix, and, you know, it doesn't really capture at that high resolution cell level. It doesn't necessarily capture, you know, rot and defects in a tree and such. So there's a gap there between what is potential in terms of standing timber volume and what I'm realistically going to be able to harvest out of a block. As part of trying to close that gap, harvester head data was seen as an important potential data stream to start working with. They definitely saw a need for improved tools to mine EFI data and other data sets, and really it was around, a lot of it was around, you know, simplified dashboards so that you know, people don't need to get their hands dirty with EFI and LiDAR data. They just needed some tools that would quickly tell them, if I do this, what will happen? I did this, how does that play into my overall plan? sort of in terms of that complexity of the value streams within New Brunswick, sort of trying to get more to a real-time understanding of wood flow, you know, optimizing the transportation from one harvest block and a product that's produced there to a mill that's receiving that product. And finally, you know, to continue a dialogue and have some important collaboration and break down some of the silos that have historically happened on sharing of this data, from, you know, the strategic forest management planning to the operational field guys to the person in the mill. So, as I said, we had this workshop in February, and then everything went cold, I feel, because everything shut down and we kind of lost our momentum to some degree. We're starting to, you know, have dialogue and discussions with folks and get back up to speed finally into the fall now. And we have made a bit of progress. So I'll highlight a few things that we've been working on this summer and into the fall. So in terms of harvester head data, we've funded a project with the Northern Hardwood Research Institute over the next 2.5 years to really start understanding what is the potential of that data stream, and really answering the question, how accurate is that data going to be? You know, under, you know, calibration scenarios, you know, how often do I need to calibrate my machines? How much real data do I need to collect to calibrate some of these relationships coming out? So they're going to put in a series of field validation plots, 1 hectare blocks essentially, so that we can start validating the data stream against, you know, stem analysis, scaling, traditional methods to measure what's inside of a tree. And then further, just generating a data set so we can really dig into the data, start understanding how do we start manipulating this data, managing the data, storing the data, sharing the data, you know, get some sense of a larger data set that we can start working with. In terms of improvement of EFI, we've been working with CanMed Energy, and we also within NRCan, we have an office of the chief scientist. The role of the chief scientist is really to advocate for the science that's done within Natural Resources Canada, be a champion for good science, and make sure that you know, that we're able to speak openly and freely about the work that we're doing and sharing our progress. Our current chief scientist has a background in AI, and they've sort of put an AI analytical team around him. And so we've been working with, they've been looking for case studies across natural resources sector. So in oil and gas and mining and forestry, in finding some case studies across the sectors where AI tools can be leveraged to come up with better solutions. So between both of those, we're using you know, advanced analytical approaches, and really I think a benefit is they're not foresters, they're not remote sensing experts. In a lot of cases, they're engineers and business analysts, and so we're giving them the data, getting them the information they need to understand the data, but really hoping that, you know, a completely fresh set of eyes on that data and thinking outside the box in terms of analytical approaches might head us in directions that we might have not otherwise thought of. So with those, we're looking at improved enhanced forest inventory and species identification. Further exploring, you know, starting to get into some of this reinforcement learning to leverage the harvest information and scaling data that actually occurred on a harvest block and feeding that back into that EFI loop. So, you know, we've got a whole bunch of inputs into building an EFI in terms of our model calibration, our modeling approach, volume equations, and so on. And then, you know, there's a whole bunch of variables around how I actually cut that block in terms of layout, stand history, time of year, equipment, and so on. And so really starting to feed that back in so that, you know, not necessarily we're improving the net merchantable volume estimate of the standing volume, but we create another volume column that is really just my operationally realistic netted down volume that I'm likely to get off of a forest block. One thing that we're doing right now is we're planning to run a survey among the forest sector in New Brunswick this fall and winter, and we really want to get a baseline understanding for ourselves of, what is the geospatial capacity within a forest company, within an indigenous community, within a private woodlot marketing board, so that we understand that up front, so that when we start developing tools, we want to make sure that we're tailoring the solutions, that can be as widely adopted as possible. We don't want to build something that, well, this is great, but there's only one or two companies that are really going to be able to either afford or have the analytical capacity in-house to continue moving that product along and keep it going. So we thought that was something important to do up front. Understand where capacity gaps are within organizations, and in a lot of cases where a data set is common amongst a bunch of stakeholders, we want to start getting an understanding of what is people's willingness to maybe relinquish some control over their data, pool it in with a larger data set so they'll get more power out of the data they're providing, but also that it takes away the burden that they might have of managing that data and handing it off to potentially a central organization. Woodflow modeling was the other priority that was identified. We're making a little bit of progress just on discussions on this one, but we really see that as starting to be the hub of where information streams are going to come in. A decision algorithm can plug in on top of that hub. Either they're common tools that many people will need, or people can plug that data stream into a more proprietary analytical tool if they have it. And so there's a lot of discussions, or there will be, on rules on data sharing and access. How do we make sure that proprietary data that might serve a broader purpose is shared in the right manner and not compromised? But really start having that hub of, I know my planned harvest blocks, I have a transportation network, I have a mill demand, and at least working with those data streams, keeping them going in a constant data stream. The province of New Brunswick built a Woodflow model about 10 years ago. It was somewhat complicated. It took a lot of work to get the data into the model, and then the model had a very short shelf life because it was a huge lift to get new data into it, and that never happened. And so we kind of want to try to keep an evergreen Woodflow modeling tool framework going, so that we can always adapt it to the needs of the day. So just a few things that we still need to address. We're having ongoing conversations and discussions on. Some of it has been delayed because of the lockdown. We were planning potentially this year to go on some fact-finding missions to Scandinavia or into the United States to just get a better understanding of who's using what's the solution provider ecosystem. We know some of these tools, there's products off the shelf, and we don't want to reinvent the wheel. Where there's a tool that exists and it can be adapted to most situations, we want to work with that. Our role in a lot of ways is to plug the gaps between marrying data sets together, understanding if I make an investment in this tool, is there going to be a payoff for me? And doing some of the more core research. As already said, there's going to be undoubtedly issues around data sharing, privacy, aggregation, hosting. That's a whole bucket that we need to address and continue dialogue, and probably get some social scientists involved to understand what is the thought process behind, why can't you share that data? So that's, those will be ongoing discussions. In terms of data standards, if a whole bunch of folks are feeding data into a common repository, how do we devise a data standard that can be adhered to and easily adopted by most people? There's a whole bunch of stuff we need to continue to do on further leveraging our remote sensing data. Where we have our LiDAR all acquired and the EFI developed for New Brunswick now, we often get the question, when are you going to fly LiDAR again? How long is this EFI good for? And so we want to help answer some of those questions. And in terms of projecting an EFI forward, there's some tools that came out of the AWARE program for that. You know, there's a whole bunch of other remote sensing tools that we can use either to do harvest updates or to grow or detect change within that EFI and extend the shelf life of that EFI beyond, beyond, you know, sort of answer the question, is this good for 2 years? Is it good for 5 years? Is it good for 10 years? And what tools do I need in the interim to keep that fresh? We're starting to think right up front. I talked about, you know, if this tool is adopted, what's my return on investment? Those are stories we're going to have to be able to tell and justify. So we're trying to think about how do we start tracking some of the economic indicators up front so that we get to the end of a project and we can start quantifying what those ROIs are and speaking in dollars and cents. And continuing the work on developing that collaborative framework so we continue to work together moving forward. And so that's about it for where we're at on those projects. And I'd be happy as we make more progress to share again with you folks as we make progress. And I'm interested, as I said up front in the first bullet point, to understand what people are doing elsewhere, so that we're not doing things in duplicate and we maximize what we can learn from others. Just a couple last slides. I guess want to get back to the geospatial side a little bit. In terms of our national research forests in Canada, we have, this is the Petawawa Research Forest, about an hour and a half, 2 hours northwest of Ottawa, about 10,000 hectares. And Joanne White is really led on this work in terms of if you just Google Petawawa Supersite, all of the geospatial data that we've collected over the years at Petawawa is now hosted online. You can just see a snapshot of the data here. So a lot of the LiDAR products, enhanced forest inventory, plot information, a lot of remote sensing data, you know, Landsat, time series data, Sentinel data, and so on. All hosted online for Petawawa. And so if you're thinking of doing a research project, you need access to good quality data. It's all available there. And really we're trying to focus a lot of research work on these research forests through making the data available. At Acadia Research Forest here outside of Fredericton, I just wrapped up year 3 of putting in, I have a 500-meter systematic grid of inventory plots. We're up to 212 plots, I believe, established over Acadia, where, you know, we have survey grade GPS locations of the plots, 400 square meter fixed area plots. Starting to build up the remote sensing side. So we've got lots of LiDAR captures and aerial photography and so on. And so again, it's another data set that's, you know, it's in the neighborhood of Maine, probably somewhat similar forest conditions. I know I've been working with Dan and Tony on collaboration. I think you guys have started to use some of this data and more broadly New Brunswick data. And so that's all hosted through ArcGIS Online. And so if you ever want access to that plot data, I can share that easily as well. And so that's it. Thanks for your time. And I think we got a bit of time for questions, and I'd certainly appreciate getting any, and hopefully I can answer them.
Thank you, Adam. Anyone with questions, feel free to speak up or drop a question in the chat box.
Adam, this is me, Anil. I just had a question on whether you take into consideration the market in your Woodflow, the Woodflow diagram which you showed.
Yeah. So we don't have a Woodflow model yet. in the previous one 10 years ago, I think generally that was integrated into it. Another project we did work on recently with the Open Geospatial Consortium was starting to work on a Woodflow model. And in that case, we did include economic indicators, commodity prices broadly, and in terms of modifying, understanding transportation costs, we were plugging into Stats Canada to get fuel prices and things like that, so that we could start understanding, around a range of fuel cost scenarios, for example, what would that mean to transportation costs and various scenarios around that. But definitely, yeah, that is where we would want to head. We would want to, have a lot of data streams coming in around commodity prices, even predicted, in terms of market demand trends, trying to predict what market demand would be for a given product, and very nimbly, possibly, I'm going to queue this harvest block up before this one now because we need more 2x4s right now because everyone's building the deck. So, and doing that while also understanding that if I do make that change now because it serves my need now, I'm not sacrificing, or I'm not closing any doors for me in the future in terms of, well, I cut all my 2x4s this month. What am I gonna produce? Where am I gonna get my 2x4s next year? So, yeah.
Thank you, Adam.
No problem.
Really nice talk.
Thank you.
Any other questions for Adam?
Hi, Adam. I'm Logan. I'm a student here in SFR studying forestry economics, and I just want to know what are some emerging opportunities in the industry to kind of understand more like technology and advancements in remote sensing. What are some things that I should be expecting on the horizon to learn?
So yeah, I mean, that again, going back to that question, when we get the question, when are you going to fly LiDAR again? The answer right now is we don't even know what the technology is going to be when we go do it again. So, but even between 2013 and 2018, the sensors went from about 300,000 pulses, laser pulses per second, up to over 1 million pulses per second. And that really changed the cost structure in terms of I could fly at a higher altitude and so on. And so, we have multispectral. If on the Petawawa super site, I believe the data is there, we have a multispectral LiDAR data set. So, and that's an emerging technology. And when we start talking about species identification, that's a tool potentially that could be there. There's 2 LiDAR sensors in space right now. So, 10 years from now, will we just get this from space? So, yeah, I guess the answer is we don't know when we acquire LiDAR again, what the technology is going to be necessarily that we'll use. There's Ontario is using single photon LiDAR, for example. So, you can fly that at a much higher altitude and cover a lot of area. So for a province the size of Ontario, that works very well to their advantage to cover large areas. So, yeah.
Other questions?
I don't want to take all the time, but then one last question from my side was like, how often do you said that you constantly get feedback to change the model, right? How often do you assimilate those feedbacks into your?
So, I mean, that's a technology question too. So one of the things that FP Innovations is working on is the Internet of the Forest. So how do we get connectivity into the forest so that potentially we could be streaming off in real time the harvester head data stream. the other, people call it sneaker net. You just, at the end of your shift, you put in your thumb drive and you download it and you walk to your truck and you take it home with you. So I don't know. I don't know if we necessarily need a real-time solution, and probably different questions need different time steps. But I think if we design it so that we could accept a real-time data flow, if we could get it, then we'll start with that basis, and then and part of the work I believe that the NHRI is planning to do is once we get a data set, we can run scenarios where we only got that data that they generated over a year. We only got that every week, only got it every month, and we can look at what are the trade-offs. So the other one we're looking at that probably is the spatial accuracy. So do I need a real-time GPS in the harvester and I know very precisely where every tree was cut? Do I need, if I'm confident that I know what 20-meter cell that tree came out of, or if I know aggregate at the harvest block what came off of it, what doors do I open and close by having different resolutions, and what is it going to cost me to get a real-time data stream that I know where every tree came from versus I only get a snapshot once a week and it's at the 20-meter resolution. So there's some cost trade-offs obviously there as well that you would need to explore.
Thank you, Adam.
You're welcome.
Hey, Adam, I have a question for you with regard to artificial intelligence, and you touched on this during your talk. What's your sense of how that will change the landscape over, say, the next 5 years? Do you see it as something that's just going to radically change things, or not so much? Because you hear a lot about that in the news.
I know, and I'm still somewhat of a skeptic, I would say. I'm somewhat competent in random forest, and that's sort of as far as I want to get myself. When we deal with these analytical teams at CanMet and the Office of the Chief Scientist, we're still building up our comfort level, and I still feel there's a lot of hype, and they're going to throw a kitchen sink of tools at it, but we still need to be able to interpret the results and make sure that it's, for example, we gave them the airborne LiDAR point clouds, 6 points per square meter, which in a forestry perspective is a pretty rich data set, but it wasn't enough data for them. They couldn't run that tool, and can you get us more data? And we're like, no, this is already pretty good data, so there's going to be that trade-off between the data resolution that I can provide and the tools that I'm going to be able to use. So, I can't tell you 5 years from now, but I'm going to be skeptical for at least another 5 years.
That makes sense to me as well. And your point on data veracity earlier, can you really have trust in the data and the predictions that are coming out of your models? Yeah. And that's always been something that I've questioned about the promises of AI.
Yeah. So we have a new employee, or he's been with us for about a year, Mathieu Faltin. Mathieu is working out of Ottawa. Strong background in growth and yield, and in particular, his focus is on teasing out the compounding error. And I've got a growth and yield model that has a mortality model, a diameter increment model, and this one, and this one, and this one. And when I mash them all together, how do I tell, did these errors cancel each other out? Did they compound? Does it still make sense? And so we're going to be working with Mathieu quite a bit as we're sort of, an EFI model on top of and then we put a volume equation on top of that. And then we put that into a growth and yield model, and then we get real-time data, we field that feedback. And so, does it make any sense? Or as we go through these steps, are we prudent about the way we constrain ourselves to make sure that we understand the error budget across all of those steps?
That's great. Thanks, Adam. Any other questions for Adam? All right. Well, thank you again, Adam, very much. That was really great.
Yeah,
And,
well, thank you very much.
And
Hopefully
thanks,
we can do this
everyone.
hopefully we can
Thanks.
do this in person next time.
Yes, yes, here, here. Thanks, everyone, for joining us. Really appreciate it. And again, this talk is being recorded, so we'll have that up on the Wheatland YouTube channel. And we have 2 more Wheatland seminars this fall, one on the 4th of November and one on the 18th. So be looking for those announcements soon.
Okay, great.
Great.
Thanks a lot,
Thanks,
everyone.
everyone.
All right. See ya.
Thanks, Adam.
Adam.
Yeah, no problem.